This is the Wolff-Kishner reaction. It's a reduction for ketones and aldehydes, and it uses hydrazine, base, and thermal conditions. And over here we have the overall reaction over now. So we start with our hydrazine and our ketone, which we're using in this example. And so the hydrazine will perform a nucleophilic attack on the ketone, and will form this compound right here. And in the next step, your base will deprotonate the compound. And because this proton is weakly acidic, we need to use heat to remove the H.
So following the deprotonation of this compound right here, we form water, which will then be deprotonated by the negatively charged oxygen, the anion, which will then render us this hydroxy group, which will then further deprotonate the compound, kicking out the hydroxy group and forming a double bond with this nitrogen, which will then result in our hydrazone. Woo! Our next step is deprotonation of the hydrazone via the hydroxy group that was released from the previous step, which will then give us water to create our imine compound. The negatively charged nitrogen will delocalize its charge to form a double bond between both nitrogens, and the double bond between nitrogen and carbon will pick up these electrons and will become negatively charged. From there, this negatively charged carbon will attack the water molecule to obtain a hydrogen, and it will release a hydroxy group at the end of this step. As you can see in this step, hydrogen was attached to the carbon. And now the hydroxy group from the previous step will come in and deprotonate the nitrogen compound, forming only a nitrogen-nitrogen double bond and water as a byproduct. So following the release of water, we get this molecule, this compound, and the following step is a rearrangement of the negatively charged nitrogen. Will form a triple bond between both nitrogens, and these electrons will be picked up by carbon to create a carbon anion, and as an end result we get nitrogen gas, and this is our product, the carbon anion. In this step, the carbon anion will then pick up a proton from the water molecule released 2 steps ago to create a alkane, and as our end result we will regenerate back our base catalyst. We made the alkane, guys. And this was the Wolff-Kishner reduction mechanism.